I'm Patrick Bailey with iqless. Today is June 4th, 2022, and in this video I'm going to talk about a new, taller version of my iqless spool holder. Okay, so here it is, the extended iqless Filament i3 Mark III spool holder. We got this extra piece in here to extend it. Now I got some funky colors going on because I had to do some reprints, and we'll definitely go over all that fun stuff. So the idea here is that normally I have just this, and that's why I had an issue. The spool was so relatively close to the top. I was okay most of the time, but if I'm starting to print those last little bit and I'm going back and forth, it's much better that the spool is further away. And so it kind of got caught up, it started moving, it bound, a lot of bad things happened when I was printing this giant bolt. So my idea was something that might help is to get the spool further away. So came up with this, and we had some failures doing it. Someone suggested, I recently printed a giant T-Rex skull that I split apart, and we used cylinders to attach, and someone suggests, why don't you use hex, which will be stronger, and the point I made is like, well, I'm not really using them for strength, I'm using them for guidance. Let's guide them in and glue them together. I'm still going to do that with this. I want to glue it together, but I thought, let's try it out, let's go do it, and it worked. However, with the circles, and I have to admit I wasn't nearly quite so long with the circles, the cylinders. I did not need, I printed the same size I made the hole. And there was enough give in the plastic, they fit just fine. You had to kind of cram them in, maybe hammer them, but it worked just fine. These though, at 100% the same size as the hole, not gonna work. They got stuck, bad things happened. I woke my wife up when I started hitting hammers early in the morning. So I had to change these. These are actually 97% the size as far as the diameter is concerned. And that worked just fine. Now they're not tight, but they're fine. They're a little loose. I don't think I can get them any tighter than that really. And my intention is to glue it. But for the purposes here, they work. You can stick them together, and I'm going to glue it, so it's kind of temporary. But it does hold together enough for a demonstration. And boom. Now, another thing, if you haven't printed one of these out, and I'm not the only one who makes these kind of things. In fact, I copy a lot of the ideas for this from someone else. If and when you print something like this out and you try to snap it on, it's not going to snap on. In fact, it's going to seem like it's not going to work. That's kind of intentional because we want to kind of make it as tight as we can. And the only way to do that is to make it where it's actually not going to snap on the first time. So you're going to need a deburring tool and probably a file. And so I had to deburr, I had to sit here and scrape this and get this really just kind of down to a nub. And then I had to use this guy, down here and especially up here. So I had to go here and kind of shave this down a lot. Just bit by bit, try it, bit by bit, try it, because you kind of want to get it as tight as you can. And eventually it worked, and there we go. So I have not tried it yet. So we'll see. So I'm going to get this glued together, and we'll try it out and see how well it goes. I think it should be fine. Also, if you're a crazy person, you could keep printing these out. So you could make it as long as you want, I suppose. But at some point, it's going to get a little too, a little too lopsided. But you could. So we'll print this out. We'll get this together and try it, and hopefully it works. So with that, let's go over the numbers and such. Okay, so first some URLs, and then some numbers, and then we'll talk about some OpenSCAD stuff. So here it is right now, so we can see this lovely thing right here. So there's the, up on Printables, it's 223270 with the extender. So, and this is just an extended version of what I made before. And if you download this file, probably the easiest thing to do is just grab the 3MF file, which has everything in there, and print everything. But here's, you can also get all the individual parts if you want to do just some individual parts. So I always put that in there. And there's also the G-code. Just grab the G-code. But also here is the one I did before, which you're going to need apart from this if you're going to go, if you want to go tweak the OpenSCAD and go over that. But no need to, but I'm going to try to be complete here. So here's the spool arm. You're going to need the spool arm because that's what we're splitting up. And we'll go over that in a minute. And then also I put out the code out here on OpenSCAD, which is A little unclean because I just used the code to create it. I didn't intend it to be something that other people might use for any reason. It was just like a one-time deal. So there's some parts of it that aren't quite as clean as they otherwise would be, but it does work. Okay, so with that, let us go over the numbers. So now in my case, these numbers cover just the parts I needed to print. So I did not need to print the arms, I already had them. So basically everything except for the two arms and the two nubs that go on the two screws, two bolts that go on the end of the arms. I didn't need that. So to print what I printed is 17 hours and 38 minutes. It took 15.3 central electricity, and it weighs 0.138 kilograms. And at $20 per kilogram comes out to $2.76 worth of material. So all in, $2.92 for my version. So roughly $3. So not too bad. And also, oh well, let me go over this before I try to move my camera here. If you're gonna do everything on the 3MF file, I haven't done this because I don't need it, but the estimates on here are usually pretty good. So you can always, you can trust them pretty good. They're probably pretty accurate. So this is gonna take, if you do everything, you're gonna take about 26 hours. And talking about 300.3 kilograms. And if you do all the calculations on this, you're talking with electricity probably less than $6.50 to print the whole thing out. So not too bad. But with that, let me see if I can get my camera here and if I can drag it over, because right now I have it running. So over here you can see from afar, it's up there and it's up high, and I think I'm gonna like it. It does give you a bigger lever arm, so you got to be careful about that, because if you get too much, I have noticed it rocking back and forth a little bit more because you have a longer lever arm. So be aware of that. Be careful. Honestly, a better solution is to have something mounted on the wall further and higher up, especially if in a permanent position. But I do like to have mine portable because I'm going to a homeschool conference, or in some cases I took them on vacation. So having that portability is definitely nice. And the shorter one has worked for me for a long, long time, but came across the problem where I was printing out the very tall. I usually don't print things up to the maximum, or especially not wide to the maximum, but I was printing out the, well, I got it down here, maybe. Nope, I don't have it down here. But I was printing out a giant thread and bolt, a giant bolt that reached the top, and it was big, very wide on the top, and it caused problems because it got too close. But this extension, I think, would solve that problem. Okay, so with that, let's go look at the OpenSCAD a little bit and kind of explain some of the stuff I was doing. So first of all, in the OpenSCAD, I am bringing in the spool arm. So let me see. Oh, I might have messed myself up here. Okay, so a lot of this is I cut up in different sections, so I just commented it out because I didn't need to make individual ones. So let's see what we got here. So basically what I did is I took in and imported the spool arms, the original spool arm for the original one, and all I did was I basically put a big cube in between. So if I do this, let me remove this difference here real quick. Boom. Oh, if I can learn how to type right. Boom. So it's just a big cube here that we can use to delete one section, or we can actually use this for intersection. So I can use one cube to give me both sections, and I'll show that in a second. So for those unfamiliar, boom, so we have that, we cut that out, and then I also have the two cylinders. So there's those two cylinders that go here, and I position them in between, so they, well in fact if I get rid of the difference, and get rid of that guy, and get rid of the cube, you should see, here's the two hex cylinders, which actually, they're not perfectly in the middle of the cut, and that was a problem I found out, because it turns out I thought I was in the middle of the cut, but I didn't cut one side deep enough, and okay. But anyway, so there's that, and to do, if you're doing cylinders, one nice thing is, if you're familiar with that, this is the height, in this case the length, because I rotated them, and there's the diameter, or I think it's the radius, don't quote me on that. But here I can change the number of faces, so 6 gives me a hex. If I did 4, I'd get a square. So you can use that to your advantage to kind of quickly do something. And I think the hex will give it more strength. Someone suggested that last time I was doing something. I said, okay, let's try that. And it worked fairly well, but we'll get in that in a minute. So that cuts it and puts that in there. So there's that piece, easy peasy, and then you render it. Okay, so next piece is the lower one, which I was fiddling with. Let's see, boom. So there's the lower piece, same thing, using the same cube, but in this case I'm doing intersection. So intersection says everything within this cube is legit, anything, where everything meets is legit, otherwise cut it apart. So that gives me the other one. I cut that in there. And now if I was only doing these two pieces, I cut them, I put that in there, I could glue them back in, those rods would work just fine. But I'm going to extend it. So let me comment that out. Boom. Come on. And here's this, just for convenience, here's those hex bolts. Oh. Let me comment that. So I just did that for convenience, that way I can get those hex bolts. Now when I printed them, now when I did a giant T-Rex that I did in different parts, and I had cylinders, rods in between so that I could reassemble it. And my intention for the T-Rex, which actually I have down here, and I have these cylinders, and these cylinders are round, and they work just fine on that. In fact, these cylinders are the exact same size as the hole, and there's enough give, and it worked just fine. However, when I went to this hex, I tried to use the exact same size, and it had problems. It was too tight, and probably because of the nature of the hex versus a cylinder, you know. So I had to go scale it. So here I tried to do some experiments with different scaling, and 97 seemed to work. It was loose. It wasn't perfectly tight, so maybe you could go a little higher if you wanted to, but 97 was good enough for me because I wasn't really using it for my intention was to, as a guide, to glue it because, hey, I eventually glued it with 3D glue, but it also gives a little more strength. So, okay, and then, oh, I think this is the other hex I did too. Yeah, that's the other. I just decided to do two since you want to do them in, arguably do them in pairs because you need 4. And then the extender, oh, I should probably do a whole video going over this at some point, because basically what you do, I should do a video on this, is you import that spool arm, so you have the whole thing, and then you kind of go right to where you cut the 2 in half, and you make a little tiny cube. So here is this, you basically, what did I do? Yeah, I did that. So I'd have to go, well, I have to go figure it out again. But basically the idea is you slice a slice. So you slice a very, very thin slice on one side, and you're like, cool, I've got that little slice. Now how do I extend it? Well, you don't exactly. So you slice it there, and then what you do is you can take that same similar, you can slice it again and move the other slice. So now you have these two slices that are cut in the same, like, you know, cutting a part of a banana, but the exact same location, so they're clones of each other. Then you move them apart from each other, and then you do a hull, and then they reattach. And this looks like kind of a hex, but you can see it's not a perfect hex because it's actually where that was cut from the original. And then after that, then you put the cylinders back in, and you cut. But then I had to be careful because at one point the cut wasn't deep enough, so I had to go re-experiment again and get that cut just right. But that's what I did. It's kind of nice that you can take something like, you can extend a lot of things. If you were to cut something in half and you knew where you wanted to extend it, you could take a slice right where you extended it, so it needs some depth, some 3-dimensional, and then copy that someplace else, do a hull, and it worked just fine. I don't have the time right now to go over all the details, but this would be another one to go back and do a detailed video showing exactly how the OpenSCAD worked. And I think I'll put that on my docket to do. And if I haven't done it in a couple months, someone remind me and I'll come back and do it, because that would be, this is kind of a worthwhile thing to learn OpenSCAD. But the code's out there, you can fiddle it with it. Might take some time to figure out what I did, but that's the basic idea. So, I like this design. We'll see how it works. I hope it'll solve my problem. I think it will. And hopefully it doesn't, I've seen it wobble a little bit, but hopefully, so far it's not wobbling too much. But also, glue it. If all you're going to do is kind of attach these, it's going to it's gonna fall apart, I think. So I like the 3D gloop, and I've done some videos on that in the past. Commercial product out there, it really makes a solid connection. So with that, let's wrap this up with a reminder that 3D printing is an engineering adventure that you're on. You can develop your skills and knowledge, and you can take this in so many ways. You can make a business out of this. You can teach others, and you can make some amazing designs. So design it, engineer it. If you want a good watch, go check out a video the 3D Printing Nerd recently put up called 3D Printing Nerd Live from Rapid plus TCT 2022. I don't know much about the conference myself, but it seems to be an industrial manufacturing one, and boy, the stuff they are showing off is awesome. I know it's not consumer level stuff, but some of the stuff may trickle down to us consumer level folks in the next 5 to 10 years. Anyway, go check it out.